Swayam Prabha. Digital India. Educated India.
Right. So, now we will go and look at the first state machine. So, to start with, so how do we educate a state machine? Okay, let me try and do that. So, to start with, there is a start state, right. So, what is a DFA incidentally? How do you define a DFA? It is a 5 tuple Q sigma delta Q naught F, where Q is the set of states, sigma is a set of alphabets, delta is a transition function from what? Q cross sigma to Q, Q naught is the initial state and F is a set of final states. This is what I want you to answer. So, it is 5 tuple Q sigma delta Q naught F, Q is set of initial states, sigma is say states, sigma is alphabets, delta is Q cross sigma to Q, right. So, very few English words. So, this is a precise mathematical definition of a deterministic finite automation. Come on. Okay, chal. Now we start. So, every fellow, okay, everything starts with invalid state, right. So, this is a start state. So, this is the state Q naught of your thing. So, when I reset, okay, every cache line will be invalid. Now, I read an address A. When I read an address A, then I go into shared state. Okay. When I read an address A, I go into a shared state because I am reading at A. So, let me say A1. So, in the main memory, let this be the processor P1, this is the cache, this is A1, let me say there is another A2. Now, let me say there is some 15 stored here and 19 stored here. Now, when I read this thing A1, I have 15, the value there is also 15, somebody else can also read and they will also be 15. So, I am in a shared state. But now, I go and tell the bus. So, whatever I am writing in red is I say I go and whenever I read A1, I tell the bus that I am reading A1, right. Okay, you are getting this. Now, in this part, after this, so again I am reading A1 or whatever I call it as read hit. When will I get a read hit? I read the same address, read A1, fine. Okay. I may also get what? Read miss. When will I get read miss? When I read A2, I tell the bus. Right? I tell the bus when I read A2 and I get a read miss. Okay? You are getting this? Yes or no? Okay. Able to follow? And when I read A2, since this is shared, right, when I read A2, I will just go and overwrite it because whatever is there in the memory is, I have 15 here, I also have 15 here. When I read A2, then I need not go and write this 15 back because it's only in a shared state. So, I need not go and write it back into the cache. You are getting? But when I get a read miss, I have to tell the bus that I am reading A2. Now, let us take the next thing. When I get a write miss, when I do a write hit, when I get a write hit, I go into an exclusive state. But I will tell bus about this write. Which address I am writing, I will tell the bus. Okay. So, let me take some color, what color, what do I choose? Okay. Okay. Now, if I get a right miss, right, I have to just replace, so I need not, but I will also tell bus. When will I get a right miss? I am already I read A1, now I am writing into A2. That means I will get a right miss here. So I have to fetch 19, or I have to write something into 19. Okay. Right miss also I will tell this thing for the same cache line. This state machine is for a single cache line. Okay. Now, what is the next thing I will get? In this state, if I get a read hit, no problem. If I get a write hit, no problem. Okay. If I get a read hit, there is no problem. If I get a write hit, there is no problem. If I get a read miss, if I get a read miss, what will I do? If I get a read hit or write hit, there is no issue because I am in exclusive state. If I get a read miss, I have to go to shared state. But while going to shared state, what I should do? I need to do a write back. Okay, I need to do a write back, and I have to tell bus also what I am reading. Okay. Now, if I get a write miss, now I am writing into A2, what I should do? Again I do a write back of A1 and I tell bus. Okay. Are you able to follow this? Any doubts? Tell the bus that I am writing into A2. I am the only fellow, no? I am the bus fellow. I have the bus. I can only read or write into the bus. So I will tell the bus, say I am writing into A2. So when I read A1, when I am storing A1 in exclusive state and I want to read A2, that means now the line after reading A2 I go to the shared state. But then I have the latest value of A1, so I will write it back there and then bring A2, but now I will become shared because the value of A2 I am storing, say probably 19 here, and it is the same as what is stored in the memory. But if I am writing into A2, that is a write miss, because currently I am storing A1, I am writing into A2, that becomes a write miss. So what I do, I will write back the latest value of A1 back, and then I will start writing into A2 and I will tell the bus, say I am writing into A2. Now I am in invalid state and I write into A2, I write into A1 or A2, whatever, right? Then I go to an exclusive state and I have to tell the bus here. So this is another thing. Okay, you all followed, right? So this is for this and this. This is what we call as the processor initiated state machine. I am associated with P1, so P1 does some transaction. Because of that, how my status can change. On the other hand, let us take the bus initiated thing. So bus initiated again, if I am in an invalid state, I do not really bother what is happening in the bus. But if I am in an exclusive state or shared state, I should see something. When will I be interested? I am not the, this is, okay. when will I be interested at all? I will be interested if something that is happening in the bus is based on the address that I am storing. As a cache line, I am storing address A. If something happens to A, then I get alerted. Okay. So I will be saying what is happening there. I am invalid, no problem. I am shared, I am storing address A. Somebody reads A, like when they read A, they tell the bus. Somebody reads A, nothing happens, I will be in the shared state. So when I see a read hit, I can say read hit means the location I am storing is what is being read. I do not do anything, okay, I just keep peacefully. Then when somebody is going to write, so I need not say read hit here, read. Somebody is going to read the same location, then I remain in the shared state. Somebody is writing into that location, then I go, oh shit, whatever. Somebody is writing into that location, then I go and make myself invalid. I am in shared state, whatever value I am storing is what is there in the memory. So somebody is writing into A, so that is where when I do a write, I say tell bus, right. So somebody is writing into A, that means he will now have the latest value, I will not have the value. I need not go and update the memory because I do not have the, so whatever I am storing is what is there in the memory, that is what we define by the shared state, right. So I need not go and update the memory there. So I just go off to invalid. So whatever I have now, he has taken control. So whatever I have is invalid. I am in an exclusive state and somebody reads, right. Then I will say stop, write back. So I am having the latest value of A, I am having 15, what is there in the memory is 10. Somebody is trying to read that address A, okay. I say hey, stop, I have the latest value. I go and write 15 into the memory, that is what I mean by write back. I will stop him, I will write back, and I will now go to shared because he is going to read it. So he will also have the value of 15, I will also have the value of 15. So now I go into a shared state, okay. When I get, this is read, so in this state when I get a read, when I get a write, I am holding A1, somebody is again trying to write into A1. So when I get a write, what I do, I will say stop, write back, okay. I am having the value of A1, somebody is writing into A1, I am having 15, so what is there is I am having 15, what is there is 11, somebody other P2 wants to write say 25 into A1, he is trying to write 25, at that point I have the value of 15. So what I say, wait, I go and write the value of 15 back and then ask him to now you go and start writing whatever you want. So I go into an invalid state, okay. Write back, okay. What will happen if that P2 write has an issue, some segmentation fault? When I do a core dump, I should know what is the latest value that is there in the memory. So that is the reason why I go and write back and then ask P2 to now go and do a write, right. It is a very interesting, very important question. Now I am having the latest value of P1 of address A, somebody else wants to write into that A. So what I do, I stop him, I go and write the value of A, whatever latest value, I become invalid because he is going to have the latest value, he is going to write something more there, okay, something other than this there, and then allow him to do the write. But why do I go and update it? I go and update it because if that fellow's thing has a exception, it goes to a core dump for whatever reason it may be, right, when it goes to a core dump, then I need to, when I core dump, I need the latest value of the location. What is a core dump? It gives you the complete state of the memory and also all the variables, right. I need the latest value, and that is precisely the reason why I go and write, and then when I get a write, I go and stop and then write back and then allow him to proceed. Okay. So these two are the state machines. Okay.